In the previous video, I was talking about my device Sticktrackr. It's a new ultra low-cost tracker, something that costs really nothing and can be deployed to a million of devices. And that has something particular is that it's using a CR2032 battery. Because it's not expensive, basically, and because this device can use it thanks to a modulation that is a bit lower, using less power than a classical Sigfox transmission and so on. And so I had a need to test different type of batteries to find a good compromise between low cost and between performance and life duration of that device on the field. At start, I found a battery from OTII. Okay, it's not really industrial and so on, but you know, I'm also a maker. I'm a blogger on this91.com, so I don't have the industrial reflex to go to a professional and so on. So here is my sourcing, and it's because it's open on Sunday, basically. That's just it. Okay, but I'm really happy from that battery. Okay, I did a lot of field tests with that, and it was really good. But I was looking for something less expensive, even if the IKEA battery is 25 cents, so it's not an expensive battery, okay? But I found different batteries. There is a no-name battery for certain of them, okay? They are about 20 cents. And also Unicell battery, which this one has a name, it's quite equivalent, but you will see that there is difference between them, and it's around 20 cents also. So I have low-cost battery, I have IKEA battery, my reference, and I have also high-end batteries. So here I've tested a Varta battery, okay, so that one is really much higher cost. I found it about 50 to 60 cents per cell. And I also have two other batteries to test. They are coming from Murata. I have two of them and they're really different and really interesting. This one is a standard CR2032 Murata battery, so I'm gonna try to test this battery and compare to the other, but this one is really the one that was interesting for me. It's a CR2032 Arc, and the R is for LP1. Yeah, no link between the letter and LP1. Okay, but this one has been made for Sigfox and LoRaWAN transmission, so that's interesting to see how it works with my device. I don't have the price for this one or this one. Okay, I'm still waiting for this information. I think they are a bit more expensive, but the main difference between that battery, which is standard CR2032 side coin, and that one, which is the same with the Air, is that this Air battery has been made to accept peak of current up to 30 milliampere, which is basically corresponding to the use case we are going to test. Okay, when that one, as a standard CR2032, has been made more for something like 1 milliampere peak, so it's really lower. So we're gonna see what is the difference between this battery and the other battery to see how I can choose the right battery for my device, and I'm going to do that with the OTII tool suite and the Arc device to do the measurement. For this test, I'm going to use the OTII suite, okay, and the Arc measurement device. And compared to the previous video where the Arc was delivering the power, here I want to measure a battery, so it's the battery that will deliver the power, and the Arc is going to measure the current and the voltage. So it's a different setting I've made for this, and this is why I'm doing a different setting right now on the interface. And for each of the battery I'm going to test, I will do a specific recording, so I will be able to compare each of them. So the second setting I have made is on my device. This device is programmed to have one Sigfox transmission every 10 minutes. Okay, it's not what's happening on the field. I accelerate things to be able to measure exactly what happened, but it's more aggressive than what I'm going to have on field, because on field it's more like one transmission every 4 hours or one transmission every 2 days. Okay, I will run this test for 2 days. for each of the battery. This is what I've done. It means that there are more than 300 transmission over that period of time, and it's basically what I'm looking for on the field as an expected duration, something like 300 transmission. Okay, so like this, I will be able to compare the different batteries and also see how they evolved, compare every one between each other during this time, and see what's gonna happen on the field. And after, I want to select the less expensive that can achieve the goal I've defined. So the first battery I selected is the IKA1 because it's my reference in terms of field experimentation, and now I'm able to compare the different battery with that one. Here you see there is a second battery I've tested. This second battery is the Unicell one, and you can see that the Unicell is really near the IKA battery. They are quite the same thing, but it's less expensive, so that's an interesting choice I have, but they are quite the same. Now I can do a comparison with the third battery. This is another low-cost battery with there is no real brand, and you can see there is a big difference with that battery compared to the two other one, because the peak, the voltage drop during the transmission start to be really higher. And the voltage drop is really important because in the first point it means that the battery will die quickly, but it also means that there is less power for the transmission. It also means that there is a risk of a voltage that is too low and a MCU reset due to that. Coming faster, so it means that on the field the life duration will be lower with that battery. We'll see how it apply all the time. I mean, this is at the beginning of the test, so it can be stable all over the test. We're gonna see that, but you see that we can see a difference like this. This fourth example is really interesting. It's the Varta one. So the Varta is a really more expensive battery, and you see that at the beginning the voltage is really lower compared to the other, and as an impact the voltage drop go really lower than the other. And basically it's something I've seen during my test. I have some device that detect a low voltage situation and reboot and stop working, even with batteries that are really quite fresh, quite new, and that's the reason why. It's because the voltage at the beginning with a new fresh battery is lower, and as an impact with the voltage drop it starts to be too low. So that's interesting to see how this battery will evolve, because it's a high-end battery, so we should have some also good things to see with that battery, and this is what we're gonna see. So now it's time to see what are the global results. So here you have a capture with all the different batteries that has been tested during that long period. I've did some tests on different periods. So we can start by selecting the whole zone and checking the IKA. We can remove the current consumption, which is not really important. And now I will zoom on the part of the voltage that is interesting for comparison. So it's easy to reduce the AS at the voltage. So now we see the important part. So you see basically on this IKA battery the voltage decrease, okay, the voltage drop. You also well see the progression of the voltage drop during the current peak, which is decreasing but quite stable all the time. So now let's compare this with the Varta one. I stopped the Varta quickly because, as you see, as I already explained, I directly see that the voltage drop is really too high for me, and so it's resting my system. But you also see that the voltage is quite stable. So compared to an IKA, where the voltage really decreased at the beginning, the Varta battery is quite stable over the time. But the voltage drop is too high in my case. So now let's check with the Murata. You know, that was really interesting to compare the Murata and the Murata Air, which are quite different. So regarding the Murata, we have something which is quite similar to the IKEA. The voltage drop is quite similar also, but it's really stable over time at the end. So let's compare with the Air, which is the one accepting high peak of battery. If we compare the standard Murata and the Murata Air, we see that basically they are following the same curve, but the Murata Air have a lower voltage drop, which can be a quite good advantage compared to the standard Murata battery for supporting high current, as it has been designed for. And in this kind of use case, it's something interesting as it reduces the risk of resetting. But yeah, that said, if we compare it with our reference, which is IKEA battery, we see that we have an advantage with the Murata Air, but this battery is quite similar to the Murata. So that's an interesting comparison between those two. So now let's go to a Kunenda battery, which is an interesting one because it's really not expensive and it's quite similar to the Murata, to the IKEA, and also to the Murata. And basically this one is a bit better than the standard Murata for my test in this context and in this duration. So that's interesting because it means that we have a good choice with a really low price. I can also compare with another one, which is the MGS CSG battery. This one is really good as the voltage drop is lower. If I compare to this no name, you see that this one is not really interesting for my use case as the voltage drop is really high. It's better than using a Varta, but it's not really interesting compared to a Kunenda solution. And no name is not easy to source, so that's interesting. The initial, and I can compare. See that the initial was quite good, but at the end of the test, there is a really big voltage drop, making it not interesting for my purpose. So basically, the best choice here I have is the Kunenda solution, which is quite interesting regarding the price of this battery. Another good choice could be the MGSGR, that the voltage drop is one of the best I've seen. And when we take a look to the Murata solution, it's also an interesting solution, more industrial basically, but I think that it has a higher price compared to the other I have. So as you can see, that's really easy with the tool to execute these different tests and to compare the different battery pro solution. You see that we really see differences. It's easy to measure. It's a bit long because I've done this test sequentially, and each of them has taken 2 days, but they have been made, automatically, so I did nothing, just pressing on run, and everything has been gathered. I know that OTII have solution for testing different batteries, but you can also have different Arc solution to do this kind of test in parallel if you have multiple battery for testing. I mean, it's not a really high investment compared to what you can do with such thing. So I'm really happy to have shared with you this battery experimentation and comparison for my IoT product. I hope that you have learned something with this and see how it was easy and good to use a OTII product for reaching such results.